This time, let's check if the given function equal to z squared minus 1 all over z plus 1 is continuous at z equal to negative 1. To do this, let's try to use the three conditions to check whether the given function is continuous at the given z, or let's say, in this case, z sub 0. Probably some of us already have an idea that this is already has an equivalent decision or interpretation with regards to whether it's continuous or not, but let's show the steps here anyway in order for us to guarantee whatever prediction we have to be true. Our given function here is z squared minus 1 all over z plus 1, and that we have here z sub 0 negative 1. Take note, negative 1 is still an example of a complex number. It's just that it doesn't have imaginary unit. It's a real number, but real number is under the complex number system. So the thing here is, first, we need to satisfy that the limit of the given function as z approaches to your z sub 0 exists. Okay? If it does, then we need to proceed to the next two to verify further. Now, take note here that if we have the limit of the given function z squared minus 1 over z plus 1 as z approaches to negative 1, we can actually use here the limit theorems that we know. Okay? Or the direct substitution that you can think of, but of course, I guaranteed that it's not all the time true to use substitution, so why not use the properties or the limit theorems if we can. But by the way, if we're going to look into this, we might notice that once you look at the denominator with z approaching negative 1, this would be equal to 0. Our denominator would be equal to 0, stating now that the limit doesn't exist. Okay, so we can say that from that point of view already, that our given function is discontinuous at z sub 0 equal to negative 1. However, take note as part of our discussion for the limits, we can of course find a way in order for this to be, what they call this one, to be simplified and for the limit to be determined. Because if we have here z squared minus 1 over your z plus 1, which is your function, we can actually factor the numerator as z plus 1 and z minus 1, your denominator being z plus 1. With that, we can actually take that out as cancellation law holds. This would mean this is equivalent to the limit of the remaining function z minus 1 as z approaches to negative 1. At this time, we can guarantee that there is actually a limit for this by using a substitution linearity property for limit. You have your negative 1 minus 1, you will get here negative 2. So earlier, by direct substitution, we might say that it doesn't exist, but actually with a little bit manipulation, the value of negative 2 is part of the complex number system. Hence, the first condition has been satisfied. Okay? You can also apply the rest of the topics that we have learned previously. Now, let's proceed to the second condition. The second condition is that f of z sub 0 must exist. Now, take note, it's automatic substitution. So you have here your function of z, which is z squared minus 1 over z plus 1, and your z sub 0 is at negative 1. So if you have f of z sub 0, or f of negative 1, okay, you will have here negative 1 squared minus 1 over negative 1 plus 1. At this time, we can no longer use the process of factoring the 2 because we are just using the automatic substitution, and we can again say that the denominator is 0. With that in mind, no matter what the value of numerator is, or even worse, because the numerator is also equal to 0, as we have here negative 1 squared is 1, minus 1 is 0. With this now, this is not satisfied. Okay? Even if we tried our best to find out the appropriate limit for the first condition, the second condition already is not satisfied. So with this now, we may not proceed to the third one into verification whether the first and second conditions are just equal, because in the first place, this is not satisfied. With this now, we can now claim, hence, or therefore, I might use therefore, but just to be parallel with the previous videos, let me use hence. Function, the function f of z, which is equal to your z squared minus 1 over z plus 1, is not, or you can of course say discontinuous, is discontinuous at z sub 0 equal to -1. Other references would like to use not continuous for emphasis, or you can just stick with this. It's not, or it's discontinuous for this, because again, the second condition is not existing, and therefore we cannot proceed to the third condition as well. That is for this type of example for functions like rational functions like this. We know that for some situations it might be continuous at some point, as long as it's at -1. If it's -2, probably it is continuous. If it's other value, it's continuous. But for -1, it is not continuous, or it is discontinuous. Thank you very much for watching.